The question we are solving now belongs to test series 11. It is of network theory subject. In specific, it belongs to transient response analysis of RLC circuits. As per the question, there is a circuit which contains a 4 volts voltage source in series with a switch S which is closed at t equal to 0. In series with the same, there is a 2 ohm resistor and another 4 ohm resistor as well. In parallel with the 4 ohm resistor, there is a capacitor of capacitance C. The drop across the capacitor is given as V of t. It is given that dV by dt at t is equal to 0 plus is 10 volts per second. From this data, we need to find the value of C. So it is already given that dV by dt at t equal to 0 plus is 10 volts per second, and it's also given that the circuit is initially relaxed. So first let us analyze the circuit for t greater than or equal to 0. So as it is given that the circuit is initially relaxed, V of 0 minus can be written as 0 plus 0 volts. So for t greater than or equal to 0, V of t can be written as Vf plus Vi minus Vf multiplied by e power minus t by R equivalent multiplied by C. Here Vf is the steady state voltage across the capacitor, which can be written by voltage divider rule as 8 by 3 volts. Please note that the steady state voltage across the capacitor is 8 by 3 volts because at steady state capacitor acts as open. Hence, the drop across the 4 ohm resistor when the capacitor is open is 8 by 3 volts. And the initial value of the capacitor voltage across the capacitor is 0 volts as the circuit is initially relaxed. And the R equivalent is the resistance as seen from the capacitor terminals, which can be seen as a parallel combination of 2 ohms and 4 ohms resistor. Hence, this can be simplified as 2 multiplied by 4 divided by 6, that is 4 by 3. So from this we can write V of t as 8 by 3 multiplied by 1 minus e power minus 3t by 4c u of t. But it is given that dV by dt at t equal to 0 plus is 10 volts per second. So for that purpose, first let us find out dV by dt, which can be simplified as 8 by 3 multiplied by e power minus 3t by 4c multiplied by minus 3 by 4c. And upon substituting or upon finding the value of dV by dt at t equal to 0 plus, we see that this can be simplified as minus 8 by 3 multiplied by minus 3 by 4c, that is equal to 2 by c. But this is given as 10 volts per second. And upon simplifying this, we see that C is equal to 1 by 5 farad. Hence, the correct option which represents the value of capacitance as per the given data is A.